Great, it's recording now. 1.7 inverse functions is what we have to talk about today. As an introduction, in real life, some activities can be inverted. For example, think about going to sleep and think about waking up. These two activities, they sort of undo each other. And if done one after the other, they kind of put you in this endless cycle, right? So that's the idea. The inverse activity will undo the given activity. Now, question for you guys. If I give you this activity, setting up a clock 1 hour forward, what should be an activity that will undo this activity? Anybody in the chat, or you can say it verbally too? Great. Someone is writing something in the chat. Let's see. Gabriela, excellent, very good. Setting it 1 hour back, right? Excellent, excellent, excellent. That definitely will undo this activity. So let's write it out, right? Let's write it out. Setting up a clock. Up a clock, 1 hour, 1 hour backward, right? Very good, very good. Yeah, great. So now, as you can see, these two activities, they undo each other, right? Now let's consider this third activity, multiplying a number by 2, doubling a number. Anyone could say or write in the chat what could be another activity that will undo this activity? Very good, Gabriela. Divide a number by 2, right? Divide a number by 2. So let's write it out. Yeah, definitely this dividing a number by 2 kind of will put you back where you started, right? So that's the idea, guys, of this inverse function. They will undo each other when applied sort of in succession in any order, right? In any order. Okay, so mathematicians came up with a formal definition. We will see that later, but you should have this in mind. The activities that we described above undo each other, right? Undo each other. Similarly, a function and its inverse function, a function and its inverse function undo each other when composed in any order the input value returns. So mathematicians consider these activities as functions, right? And when you represent function, very often you use this machine idea for the function, right? Let's take, for example, the last example and formally represent this multiplying a number by 2 by this function, f of x equal 2 times x. And if you consider this as a machine, 2x should go here, right? And let's consider the other function, dividing a number by 2 as g of x equal x over 2. And here x over 2, when you consider it as a machine, right? Now, suppose you take this input value, 3 enters the first machine. Input value 3, the function f will double it. So we will get here 3 times 2, 6, right? 6. Now, remember, when you do composition of functions, the output of the first function becomes the input of the second function, right? So if you put now 6 over here as the input for the second function, 6 divided by 2 gives me just the number 3, right? 3. So as you can see, this number and this number are the same, right? The same. So that is what I mean when I wrote here, input value returns. So these two guys, same. Same input value returns, right? Yeah. So if you can verify that this is happening for two functions in this order or in this other order, then you got yourself what mathematicians call inverse function, right? Inverse function. So here is the formal definition. F of x and g of x are inverse functions of each other, right? If and only if f composed with g will give you back the input value x, right? And g composed with f also gives you back the input value x. Now, since these inverse functions, they sort of switch input and output values, then the domain of the inverse function g will be the range of the original function, right? And the range of the inverse function will be the domain of the original function, right? Okay. Great. So now let's start with an example here to show formally when two functions are inverse of each other. Well, suppose they give you this function, first function here, x minus 2. And this other function, x plus 2. These two functions, x minus 2 and x plus 2, are inverse of each other since the following happens. If you do the composition f composed with g, remember the g function is x plus 2, right? So f of x plus 2, evaluating x plus 2 here, gives us just, after canceling the 2's, x. So checks the first condition, right? This is condition check. G of f of x. F of x is x minus 2. So g of f of x should be equal to x minus 2 plus 2, right? But notice negative 2 and 2, they cancel, and this is equal to x, satisfying the second condition, right? So formally, you can say that these two functions are inverse of each other, Okay, now some notation here. The inverse function of f of x is denoted as this, f inverse of x. This is read as follows, read as f inverse of x. This is the notation mathematicians have chosen to identify an inverse function, okay? Warning here, do not confuse this -1 here with exponent -1. It's not exponent, right? It's not that they're telling you to do 1 over f of x, no. Instead, they're asking you to figure out the inverse function, right? The inverse function, okay? Yeah, let's make this closer. Okay, so great. That's the notation that we're gonna use. Now, there is a big fact here that mathematicians discover. Just like not all activities can be inverted, right? Not all of them. Think, for example, of taking some fruits, some vegetables, making juice. That activity cannot be inverted, right? There's no way to go from the juice back to the fruits to the vegetables, right? That you use, right? So some activities cannot be inverted. So in the same way, not all functions are invertible. A function is invertible if and only if it is a one-to-one function. Only the one-to-one functions can be inverted. Only the one-to-one functions have an inverse function, okay? So now I'm gonna ask you to figure out, well, we're gonna do it together as example, right? It says, given this function f of x, x plus 8. First, they say graph f of x, graph the function. Second, they say show that the function f of x is invertible, right? And third, find the inverse function of f of x. Okay, so let's start with part A, graph this function, right? This is a linear function, right? The slope is this invisible one, right? So when you graph this function, you start with this 8. This is the y-intercept, right? Y-intercept. And you know that this y-intercept goes somewhere up here, right? Suppose it's here, this y-intercept 8. This is the point 0.8. From there, you take this as your slope, and then you can graph this, right? You go 1 to the right, 1 up. You look at the scale, so it's gonna give you a line there. Okay, yeah, taking different scale for the x-axis, the y-axis, but more or less should give you something like this, right? Yeah. Yeah, a line, right? A line. So now that line, the graph should show this, right? Let's say this is the line. Again, the scale is not exact, it's 8. Yeah, but you get the idea. This should be, the slope should be 1, right? But now they want you to show, after you graph this, they want you to show that this function is 1 to 1. We have a test, which is called the horizontal line test to do that, right? So the horizontal line test says draw horizontal lines. If all the horizontal lines meet the graph just once, right, at one point, then it means that the function is 1 to 1, therefore invertible by the fact, right? That we wrote. So this is function, so right here, using the horizontal line test, f of x passes the horizontal line test, right? And try to recall this for your homework, guys. Passes the horizontal line test. Then this function is invertible, right? Then f of x is 1 to 1. Then f of x is invertible. Very good. Okay, great. Now, part C says find the inverse function of f of x. So find this f inverse of x, right? Now, the function is very basic, very basic. Any of you guys would tell me what is the inverse function of the function x plus 8? What do you think should be the inverse function? Anybody? What is the function that will undo this x plus 8? X plus 8. Sorry. Yeah, anybody could figure out what will undo adding 8 to something so that we can go back to the input value? Yeah, I see it. Yeah. Gabriela, excellent, right? X minus 8, right? When the function is elementary basic, it's not hard to guess what should be the function that will undo this, right? You kind of think of the opposite action, right? You know, to counteract adding 8, I have to subtract 8. Yeah, good, right? But the thing is, functions are not basic all the time, right? There are some complicated functions. So in some cases, you may have to follow a method, an algorithm to find the inverse function, right? Mathematicians thought of that, and they came out with a method that when followed, right? It has 4 steps. When follow this method, you will be able to get the inverse function of any invertible function, basically. So I'm going to explain that method to you for the cases when it's not obvious what should be the inverse function, okay? So method to find the inverse of a function. Given any one-to-one function f of x, follow the steps below to find its inverse function, f inverse of x, right? Remember, f inverse of x. First step, replace f of x with y. Very easy step. Just replace f of x with y. Step 2, switch x and y. Remember, the inverse function compared to the original function, the output value becomes the input value and vice versa, right? That justifies this step. Step 3, solve for y. This is the longest step. I will explain to you. And step 4, replace your y with f inverse of x, right? This is just for a final notation. All right, so let's explain how this method works. Example 3, find the inverse function of this function, 4x minus 7, 4x minus 7. So solution, start with the step 1, right? So let's write a function here, f of x equal 4x minus 7, right? This is the original function. So we're gonna start with the step 1, which says replace f of x with y. So you simply do this. This guy that you see here, instead of f of x, write y. This is a very simple step. Just replace y with f of x. Y instead of, right? So y equal 4x minus 7. Step 1, done. Step 2. Step 2 says switch x and y. Switch x and y means when you see y, you're gonna write instead x. Where you see x, you're gonna write y. Right? Easy step 2. Step 3, the longest step, is where you're gonna do some algebraic work. It says solve for y. Solve for y. Solve for y meaning isolate y, right? Isolate y. I'm gonna write it within parentheses here. Isolate y. Get y by itself, right? Y itself. So in order to do that, first step, for instance, I can add 7 to both sides, right? Or just transpose this, changing its sign, right? Either way. So here I will have x plus 7. Here for y, notice minus 7 plus 7, 0, right? And what should be next to finish isolating this? Anybody? What's the next step to isolate y? Divide both sides by what number? Yeah, very good, very good. Very good, very good. By 4. Excellent, right? Yeah, very good, very good. Great, great, Gabriela. Very, very good. So dividing by 4 both sides, then you're gonna accomplish the following. Look, y equal this guy, x plus 7 over 4. Y completely isolated, right? Y completely isolated. Now, the step 4 is an easy step, but before we do step 4, very often the isolated variable should be on the left, the other stuff on the right, right? So let's just rewrite it. I just put this here, put this here. Step 4 is a step that deals with the final presentation of your work. Look, this is the inverse function, right? So replace this y with f inverse of x. F inverse of x will be x plus 7 over 4. You follow, guys? That's the last step, step 4. So 4 steps, you follow them, and you will get your inverse function here. Very good. Here is another example. Let's follow the 4 steps again. Step 1 says replace this f of x with a y, right? Y equal 5x plus 2 over 3. Step 1. Step 2, Step 2, switch X and Y. So where you see Y, you write X instead. Where you see X, you write Y instead, right? Y instead. So we get this. Very good. Easy step. Step 3 is the longest step. Step 3 says isolate Y. Isolate Y. You're gonna follow some algebraic steps here. So here, I want to get rid of this number 3. So allow me to multiply both sides of this equation by 3. Right? Times 3 times 3. And then I will get 3x equal, notice this will cancel, right? The number 3 is there, the denominators are gone. And then subtracting 2 or transposing 2 to the other side, changing its sign, will lead to this. 3x minus 2 equal 5x, right? 5x, or 5y, sorry. 5y. Yeah, very good. And then as we did before, the last step is division by 5, right? Division by 5. So divide by 5 both sides of this equation, and you should get y completely isolated. Y equal 3x minus 2 over 5. Now, often again, mathematicians prefer to have the isolated variable on the left, right? The rest of the stuff on the right. So let's just do it. Let's put it here. Let's put this here. Step 4 deals just with the final presentation of your work. You are saying that this is your inverse function, right? So the notation for the inverse function is this, f inverse of x. So f inverse of x will be 3x minus 2 over 5. Okay? So we follow the 4 steps and we got our answer. Very good, very good. Yeah, before going over example 3, I want you to do some work now, guys. So let's go to the worksheet here. And then I will go back to this for more examples. So let's start with the basic idea of identifying when a function is invertible, meaning when a function is one-to-one, right? So here in the first exercise, they're asking you, does the graph represent a function that has an inverse function? So hint, use the horizontal line test. So go ahead, please, and do this. Horizontal line test. Okay. So meaning draw horizontal lines and check, right? How many times these horizontal lines hit the graph. If they all hit the graph only once, it means that yes, you got yourself one-to-one function, therefore an invertible function, right? Aha, Gabriela, if it touches more than one point, it is also possible in inverse function? No, it has to touch only once in general. It has to touch only once, no matter what horizontal line you draw, the intersection should be just one point. Otherwise, you have to say, no, it's not an inverse function, right? Yeah, so what do you think is the answer, guys? Write the answer on the chat, please. Feel free to try. Is this, does this function has an inverse? Meaning, is this function one-to-one, right? Ah, I see, answer here. Yeah, very good, very good. Excellent, Gabriela. You made my day. No, right? Because notice, if you draw horizontal lines, look, 2 points of intersection, right? In general, you may say, Professor, but what if you draw a horizontal line right there at the vertex? Yeah, right there, yes. In particular, you may find some nice horizontal lines that will hit the graph once, but in general, the rule says if in general they hit the graph more than once, then no. What about number 2? Yeah, let's put this back. Right? Yeah, let's put this back. Yeah, what about number two? Try to number two now. Yeah, let's redo this. Yeah, this one now, right now. Try to do this now, guys. Number two. Is this a one-to-one function? Is it invertible? And again, hint, use the horizontal line test, right? Horizontal line test. Aha, excellent, excellent, Gabriela. Now, yes, right? Yes, because if we draw, let me make it bigger so everybody can see. If we draw horizontal lines, notice that in general, one point of intersection, right? Even right there, one point intersection, right? One point of intersection. So this one, yes. Very good, guys. All right, so try to remember that when you do your homework, they're gonna ask you to do this test, and be careful there, guys, because since this question related to this part is gonna be sort of multiple choice, like true or false, the attempts are limited. For example, if it's a true or false question, just one attempt. If it's multiple choice, there are 4 choices, 4 attempts, for obvious reasons, right? So be careful there. Okay, so do it carefully. Yeah, the other questions, as usual, they have most of them infinitely many attempts. Okay, great. So now I'm gonna ask you to do number 3. Try to number 3. Follow the 4 steps, right? And see what you get there. Number 3, number 3 is pretty straightforward. Probably we could do number 4. Yeah, number 4 looks better. Yeah. Can you try it? Yeah, number 4 looks maybe more challenging. Can you figure out following the steps? If what is the inverse function of this function, right? So hint, follow. Yeah, find f inverse is the question, right? Find the inverse function. F inverse of x. Hint, follow 4 steps method, right? Because very often you will be given complicated functions, right? It will not be obvious what's the inverse function. So for that, follow the 4 steps, and then you should get your inverse function, right? Go ahead, guys. Let's see. Yeah, try, guys. Yeah, there are some comments there. Very good, very good. Let me see. 4. Follow the 4 steps, guys, and then that should tell you, right? Yeah, sometimes may not be obvious. Very good, very good. Yeah, very good, Gabriela, very good. Yeah, so yeah, follow the 4 steps, and then we should be fine. Remember step 1, which probably I should write out here as a starting point. Step 1 says simply change this f of x for a y, right? Y equal 3x plus 1 over 4. This is step 1. Step 2, switch the variables, right? Where you see y, you write x. Where you see x, you write y. Right? And step 3, the longest, is solve for y, right? Yeah, so try to complete it. Yeah, very good. Gabriela figured it out. Yeah, excellent. Yeah, on your homework, you're gonna be giving some challenging functions, but follow the 4 steps. I have included some videos for the questions that are complicated. So if you watch the video, you can get a reference. Follow that, and you should be able to figure out the inverse function, right? Mhm. Okay, so let's see. Okay, guys, let's continue then. Step 3 should be solve for y, right? Solve for y. So we're gonna start with is this. I'm going to eliminate this denominator 4. For that, I'm going to multiply both sides of the equation by precisely the number 4, right? I want to get rid of this denominator. So as a consequence of that, I will get 4x equal 3y plus 1, right? 3y plus 1. I have to solve for y. So I'm going to subtract 1 in each side, and I'm going to get the following. 4x minus 1 equal to 3y, right? And then dividing both sides by 3, both sides of the equation by 3, I will get y completely isolated, right? Is this. Let me just write here y equal 4x minus 1 over 3, right? The isolated part on the left, the rest on the right. And the final step, guys, believe it or not, is just a step that deals with a presentation, with a final presentation of your work. It just says replace this y with f inverse of x. F inverse of x will be 4x minus 1 over 3, and done, right? This is the inverse function. So very good, this guy. Inverse of x, 4x minus 1 over 3. Now, there are some functions here that deal with radicals, some others that deal with exponents, and this special case. So, exponent. So let me give you more examples, okay? So let's go back to the lecture, and let me show you one more example here. 2 more examples, so we can go over that together. Okay, example 3 says, given this function, g of x equal x squared minus 3, it's a quadratic function, with domain x greater or equal than 0. Just this part of the parabola, right, when graph. Find g inverse and its domain. Okay. For the graph, sometimes students ask me, Professor, how did you figure this out, this graph? Well, it's a parabola that has been shifted down 3 units, right? We did transformation, remember? So the parabola originally here goes down 3 units and appears here, right? And they are saying that the domain, for the domain, they are taking just positive input values. So it should be just this part of the parabola, right? Now, if you want to graph it using our Desmos graphing calculator, it's also possible to do that. Look, you just have to type here x squared minus 3 or y equal x squared minus 3, doesn't matter. Between braces, you have to say that x must be greater or equal than 0, right? You have to tell our grapher that we want this graph, but just for x greater or equal than 0. And notice how it shows what I have here, right? Very good. Bravo. All right, now, they probably have given you the graph of the function for you to see that this graph, not the whole parabola, right, but just the right part of the parabola is 1-to-1 because it passes the horizontal line test, as you can see, right? So this is 1-to-1, so therefore it's invertible, okay? All right, so now they want you to find the inverse function, right? So let's follow the 4 steps. And we follow the 4 steps. Step one says, change this guy, the g of x, for a y, right? For a y, yes, right, y. And then this stays the same, x squared minus 3. Step one. Step two. Step two says, switch x and y, right? Where you see y, you write instead x. Where you see x, you write instead y. So this is what you get when you switch the variables, right? Step three, the longest step, says isolate y. Get y by itself, right? Get y by itself. So we have x equal y squared minus 3. We're going to get this y by itself. For that, I'm going to start by adding 3 to both sides of the equation. So this will be x plus 3 equal minus 3 plus 3 is 0. So y squared here, right? Now, question for you guys. What should be the next step to get y completely by itself? Anybody could tell us or write on the chat? What shall I do to both sides of the equation? Great, I see some activity in the chat. Yeah, there are 2 students suggesting. Aha, Sarah, very good, Sarah, you made my day. A square root, I take it for Gabriela also. A square root on both sides, right? Excellent. On the other side, and keeping y on the other side. Well, take a square root on both sides, right? Yeah, but when you do that, when you do this square root here and here, it comes with a price. You should write formally plus and minus, right? Plus and minus. We talk about that, right? But notice the graph is dealing just with the positive part of this parabola, right? So only for positive part of the parabola. So because of that, since you are assuming that this guy is just related to this positive part, then you don't have to put the plus minus. You follow, guys? The plus minus will be if you will be dealing with the whole parabola, but we're going to use with the half, right? Positive half between quotation. So therefore, this will be just y equal a square root of x plus 3. Okay? Yeah, very good, very good. And I say positive between quotation because it's going to be tricky. You will see when I find its domain. Okay, so this is the function, right? Step 4 then should be this. Step 4, y is replaced with f inverse, right? F inverse x equal a square root of x plus 3. That's it, right? This is the inverse form, right? Now they want you to figure out the domain of this inverse form. And to be formal, since they're dealing with the g function, this should be g inverse, right? So let's be formal. G inverse, g inverse of x is a square root of x plus 3, right? Now they want you to find its domain, right? Well, notice that for this function to make sense, the inside of the radical, which is called the radicand, must be greater or equal than 0, right? So this shows that once you subtract 3 in both sides of this inequality, x should be greater or equal than -3. -3, right? -3. So this, when graph is just a horizontal shift of the graph of g of x equal square root of x, right? Which is this, right? But this is telling me move or shift these 3 units to the left. Remember, it's counterintuitive, the horizontal shifts. So you go here, right? You follow, guys? So this is the graph of this guy, right? Graph. So this is the graph of G inverse of X equals square root of X plus 3. Now, by looking at the graph, anyone could tell me what should be the domain of this graph by looking at this graph, meaning what is the farthest you can go to the left, what's the farthest you can go to the right. Hint, here infinity, here minus infinity. So what should be the domain of this graph? Yeah, you gotta see where it starts, horizontally speaking, right? And where it ends. Aha. Gabriela, excellent. Excellent. Bracket. Yeah, bracket, because we're including this -3, right? This -3 is part of the graph. Bracket -3, comma, and then you go all the way to the right to infinity. You never reach infinity, so with parentheses. Excellent. See? Yeah, very good. So done, right? Done. Very good. This is for the case when they give you a function that has exponents, right? Okay. Now, let's take a look at this other example. What if they give you something like this? A rational function. F of x equals 3 over x minus 10. Find the inverse function of f. So we follow the 4 steps, right? Again, step one says, instead of this guy, f of x, write a y, right? A y. The rest stays the same, 3 over x minus 10. Step two says, switch the variables. Where you see y, write x instead. Where you encounter x, write y instead, right? Switch the variables. Step 3, the longest step, isolate y. Get y by itself, right? By itself. So for that, we are going to follow some algebraic tricks here. Well, this time the denominator is expression containing a variable, right? But this shouldn't prevent me from multiplying both sides precisely by this denominator, y minus 10. That's what I'm gonna do next. I'm gonna multiply this guy, the right side, by y minus 10, and also the left side by y minus 10. You gotta do it in both sides so you keep the equation balanced, right? So now, this clearly cancels, right? These two guys, they cancel, this and this. This, applying the distributive property, will give me x times y minus 10x, right? This part is 3 because it's cancelled. All right, next, in order to isolate y, remember, we are looking for y by itself, right? So this should be isolated. I should get rid of this, right? This guy, or transpose this to the other side, changing its sign the same. I just add 10x, right? And advice, guys, if the equation is complicated, do this carefully, okay? So this will be 3 plus 10x, or 10x plus 3, doesn't matter really, okay? Just write 3 plus 10x. All right. Finally, I am about to isolate my y, right? I'm looking for this y by itself. So to do that, I have to divide both sides of this equation by just x, right? X, I'm gonna get rid of this. So this cancels, and y finally by itself equal to 3 plus 10x over x. X over x, right? Great. So step 4, final step. This step deals with the final presentation of your work. You are saying that this is the inverse function, right? So let's write it formally as the inverse function. F inverse of x equal 3 plus 10x over x. And then we are done, right? We are done. Okay, guys. So follow these 4 steps and try now to do the following. This will be good. The first one, this with a cubic root. Yeah, we'll do it at the end. The first one, let's do this cubic one. This, and then we'll go backwards. Can you figure this out? This one. Find the inverse function is the question. Yeah, very good. Find f inverse of x. So follow the 3 steps, guys. Hint, follow the 3 steps. The 4 steps, sorry. Hint, follow 4 steps method, right? Yeah. And try to remember this method. It's gonna help you a lot in your homework, okay? Step 1, step 2, step 3, which is gonna be the longest step, and then step 4, the presentation step, right? Yeah, go ahead and try to figure this out. What should be the inverse function of f of x equal x cubed minus 8? Maybe I should write it here in case you don't see it well there. F of x equal x cubed minus 8 is the original function. Follow the 4 steps. If you successfully get your y isolated, then it means that the function is 1-to-1, right? There is a choice there, not a 1-to-1 function. Yeah, that is for the case when the function is not 1-to-1, right? But it will be very rare. In this case, we are dealing with a cubic function, right? Looks like a chair. I've been shifted down a unit, so it's 1-to-1. So just go ahead with the 4 steps and try to figure out the inverse function, right? And then we'll talk about property. Okay, guys, let's do it together, okay? Step 1 says change f of x for a y, right? Y equal x cubed minus 8. Step 1. Step 2 says switch the variables. Where you see y, write x. Where you see x, write y. This is what we get, right? Step 3 says isolate y, right, to get your inverse function. So I'm gonna add 8 to both sides of the equation. I get this after canceling these 2, right? Then I am going to take cube roots in both sides to eliminate this exponent 3. Cube roots, okay? So next is cube root here, cube root here. Remember, when the index is odd, you don't have to put the plus minus, right? We talked about that before. So finally, cube root of x plus 8 should be equal to y. Yeah, allow me to write this way with y isolated on the left. And I am ready then for step 4. Step 4 says simply substitute this y with f inverse of x, right? This is your inverse function, right? So cube root of x plus 8. Cube root of x plus 8. So this is it, right? You follow, guys? Yeah, any questions? As usual, let me know. Great. So this was a nice exercise. Now let's go over the other form so you can master this. Number 6. Can you try this? Do this now. Function here, f of x equal 2 over x minus 5. They are looking for the inverse function, right? Follow the 4 steps. Step 1, step 2, and so on. Uh-huh. I see, I see. Students figuring this out. Oh, okay. Yeah, Gabriel is asking a good question, right? Notice that on the choices, there is an option that not one-to-one. How could we know in advance, a priori, right, if the function is one-to-one? Well, for example, here, right, in the previous, you can use your tools. I said, right, I know that the shape of the QE function is a chair-like. This is a chair-like shifted 8 units down, so will stay, it will still look like a chair, so it will be one-to-one. But if not, if that's not clear, use your grapher. Look here, your Desmos graphing calculator, y equal x cubed minus 8, and you can see the shape of the function there. Apply the horizontal line test. Look, every horizontal line meets the graph just once, right? Just once. That is why it's one-to-one, right? That's why we went ahead. So now is it clear, Gabriela, how you figure this out? If needed, use the grapher if you want to double check that it's invertible, right? Yeah, but okay, yeah, use. Yeah, great, very good now. Yeah, clarify things. Yeah, this one also, right? You can graph it and you will see that it will pass the horizontal line test. So the idea of this is to follow the 4 steps of this exercise, but you can double check always with your Desmos graphing tool, right? If it's one-to-one. Yeah, go ahead. Step 1, step 2, step 3. We'll move on. Okay, let's do it together so I can talk to you about the property related to the graph of these functions and the inverse functions. Step 1 says substitute or replace f of x with y. So y equal 2 over x minus 5. First step. Step 2, switch the variables. So y becomes x and x becomes y, right? Step 3, isolate y. Isolate y. So how can we isolate y? Well, we can multiply both sides of this equation by the denominator, which is y minus 5. And as a result of that, we're going to get, let's continue our work here. This times this is just xy, x times 5, 5x, right? Just apply the distributive property there. These two guys, they cancel, so this is equal to 2. Since my intention is to isolate this guy, then let's get rid of 5x, right? Let's get rid of 5x on the left side. Adding 5x to both sides of the equation, I get x times y equal 2 plus 5x. And finally, dividing both sides of this equation by x to get y completely isolated. Look, notice this cancels here, and y equal 2 plus 5x over x should be our final answer. There is this step 4, just to deal with the presentation. Y should be substituted with f inverse of x, right? F inverse of x equal 2 plus 5x over x. 2 plus 5x over x, which is here, right? Yeah. 2 plus 5x is the same as 5x plus 2, right? So very good. Yeah, excellent, guys. So this is this. Great. Now, you can do the others at home, probably. Yeah, you can do the others at home. Let's talk about this property between the graph of the original function, the given function, and the graph of the inverse function. So remarkable property. The graphs of f of x and f inverse of x are reflections of each other about the line y equal x. The line y equal x, when graph is this, right? Y equal x is this diagonal line. And what this property is saying is that when you graph the original function, let's call it f of x. And when you graph the inverse function of f of x, f inverse of x, the two graphs are mirror images of each other, right? With respect or about this diagonal line, y equal x, right? Reflections of each other, right? About this diagonal line. Now, sometimes students ask me, right, Professor, if I have a point here, let's say this point, how can I find it on the other side of this diagonal line easily? Well, one way is to draw a perpendicular to the diagonal line like this, a perpendicular, right? 90 degrees here, and then continue and go away from that line the same distance, equidistant, right? And then this is where the other point should appear. So this green, red point should appear here, right? Yeah, that's one way, but it's geometrical, right? Kind of sometimes students cannot follow. If you cannot follow this, another way is this. Look at the coordinates of the original point. And this is actually going to help a lot on your homework. Coordinates of this point in the original graph, f of x, are 2, comma, right? 2 to the right, 1, 2, 3, 4, 4 up, 2, 4, right? This is on the original graph. Over here, just switch. The output becomes the input becomes the output, switch. And as a result, you're gonna get the coordinates of this point on the other side of the diagonal line. So this should be, look, 4 first coordinate now, and 2 second coordinate. You follow that, guys? Probably it's easier, right? Switching the coordinates, you can get easily the points on the other side, right? Mm-hmm. Now notice this point and this point stayed the same position because this is 0, 0. When you switch 0, 0, it's still 0, 0, right? This is 1, 1. When you switch 1, 1, it's still 1, 1, right? But the others, look, for the other points, you know, when you switch the coordinates, you end up somewhere else, right? Very good. All right, so now I want you to use this property, and we're gonna go over this example, and then we can take the break. It says, given this, the graph of this function, f of x equal x minus 3, for x bigger or equal than 3. The graph of this for x bigger or equal than 3 is just this, right? It's just the graph of the parent function f of x equals square root of x shifted 3 units to the right. Remember, for horizontal shift is counterintuitive. So this is shifted 1, 2, 3 units to the right, and then you draw the graph of f of x equals square root of x, right? It's here. Great. Now, they say question part A says find f inverse of x, and part B graph f inverse of x, right? Graph. So for part A, we have a algorithm, a method, right? Follows 4 steps, right? So step 1, I replace this f of x with y equal square root of x minus 3. Step 2 says switch the variables, right? So x should be equal to y minus 3, right? Where you see y, you write x instead. Where you see x, you write y instead. Step 3, the longest step, isolate y, right? Isolate y. To isolate y, what should we do here? Well, notice I have a square root here, right? What would cancel this square root? Well, what will cancel this square root is squaring, right? Squaring, doing basically the opposite, right? So these two is going to cancel the square root. And then here I will have y minus 3 equal x squared, right? And finally, adding 3 to both sides of this equation, I will get that y is equal to x squared plus 3. okay? Rewriting it this way with y isolated on the left, y equal x squared plus 3 is basically the inverse function, right? So step 4 is just for the presentation of the work. This is gonna be the inverse function of f is equal to x squared plus 3. This is the inverse function, right? Now, they want you to graph this function part B, right? Part B, let's do it here, part B. They want you to graph this. But let's kind of use our, the fact that the property that we stated, right? Which says that once you have the graph of your original function, the graph of its inverse should come for free because it's just a reflection of the graph of the original function, right? Remember, the graph of the original function was this, right? 3 units to the right. This was the graph of f of x, square root of x minus 3, right? It's here. It was given here, right? Now, what should be the graph of the inverse function? Well, one thing you can do is you can draw your diagonal line here. You draw the diagonal line and you just take the reflection. And try to record this for your homework, guys. All right. So this point in the original graph is 3, 0, right? On the other side of y equal x, the diagonal line, you switch. This will become 0, 3, right? But where is 0, 3? 1, 2, 3. 0, 3 is here, right? So it's here, let's put it here. And so on, right? Everything should be reflected here. So if everything is reflected, you will get something like this, like half of a parabola, right? Consistent with this one, half of a parabola. So it would be like that. Yeah, if you don't see it, you can take more points, right? For example, you can take this guy. This is 4, comma. If you put 4 here, 4 minus 3, 1, square root of 1, 1. This is 4, 1. Where is 4, 1 over here? At 1, 4, right? 1, 4. So, follow, guys? 1, 4. You switch, right? You switch this here, this here. Just like we did here, right? And then you connect the dots and it's the parabola, right? Yeah, to this question, guys, try to figure out what should be the answer here, A or B, based on the fact that the graph of a function compared with the graph of its inverse function, they are reflections of each other with respect to this diagonal line, right? Diagonal line. So try to reflect your graph about this diagonal line y equal x. It's like placing a mirror here, right? Mirror, and look at the image over there and see which one should be the answer, A or B, okay? And then we will move on to the second part, linear functions. Maybe we'll make it a little bit bigger so we can see. And this should serve for you to do your homework also. This is a very nice question. Gabriela, let me check. Gabriela, excellent. Yeah, you got it. You got it. Very good, very good. Excellent. Yeah, very good. So I would suggest, right, if you don't know how to draw perpendiculars and go the same distance away from the line, maybe we can work with the coordinates, right? Probably it's easier. So for example, the coordinates of this point, since it goes right through the line, and this line has input value equal to output value, the input value will be equal to the output value. When you switch, you will get the same point. So this point is there, right? It stays there. Now, what about this other point? Look, this guy in here is 0, 2, right? 0, 2. Let's make it nicer here. 0, 2. 0, 2, this, right? When you go over here, you switch 2, 0. This is 0, 2 here, 2, 0. So this point will appear here, 2, 0. Right? So 2, 0. Right? So this point appears here. This point stays there. So more or less, this is like this, right? You can see the mirror image. And then this part is going away here. This part should go away here, right? Yeah. Then the same here, right? You can take points or just take the mirror image of this over here. So this will go like this, right? Mm-hmm. Right? So therefore, this guy, right? You follow, guys? Yeah, use coordinates and switch them to determine clearly where the points are, right? The ones along the diagonal line, they stay the same. Very good, very good. So this is it.